Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great event on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you missed any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is Unleashing Developers' Full Potential in the Cloud Native Era. Our speaker today is Mark Lavie, who is the Principal DevOps Advocate at Nutanix. Mark, thank you so much for joining me today. Glad to have you here.
Thank you, Charlene. It's a pleasure.
Great.
Welcome, everybody, and thank you for your valuable time today. I'll just give a very brief introduction as to who this person is speaking to you. My name is Mark Lavie, and as the Principal DevOps Advocate at Nutanix, I get excited every day helping employees, customers, and partners really unlock the potential of DevOps. And we will filter that through the lens of how cloud native enables developers today. The very brief history of my career is that I inadvertently started up as what we would now call a full stack developer at the first national internet service provider in the early 90s. And so that was prior to the rollout of the commercial web. And so I became a very early web developer, splitting my time between teaching myself programming as well as splitting time in the data center, making sure that the code was scalable and performed well. That made me join as an early webmaster at Netscape, Silicon Graphics, CNN, and News Corporation. So worked at very large real-time media properties as well as a number of startups in Silicon Valley for over 20 years as an engineering and operations manager. So really, I've seen the birth of the web, I've seen the birth of the cloud, and I've now seen the birth of cloud native. And it's a wonderful confluence of how we build to the best of everything that we've encountered throughout my entire career. And I'm going to hopefully confer you the best of my benefit and perspective of the experience of how we got here. So with that, let's begin. Our agenda is very simple. We want to justify why we want to use cloud native to unlock agility and scalability, the impact of this on the software development lifecycle, the logical way of delivering software today and packaging software and operating software today with containers and Kubernetes, and really then take a step back to analyze all of the permutations of how we can apply these techniques and approaches. And ultimately, that architectural and operational model really has a profound impact on the teams, architecture, infrastructure, and operations of every business today. So let's get started with the beginning. Let's try to justify what is and why do we want to go to cloud native. Long story short, I won't read this to you word for word, is that we have the Cloud Native Computing Foundation, which is an open source governance body that very much helps the governance of many open source projects, including Kubernetes and Helm. And they attest for how we can basically adopt these cloud native technologies, but do them in an open manner with portability and without vendor lock-in. This means that we now have a level playing field to adopt these technologies and methodologies and really select the best from the market and innovate on top of that market as much as we want and contribute that back to the market as we want to see. This has led to an unprecedented amount of innovation in this space, and really there is almost arguably no other way to build your business at this point in time from this point on forwards without factoring cloud native and all of the other implied technologies and methodologies behind it. And that's where we're going to go for the rest of this presentation. One other important fact of note is that the CNCF not only organizes KubeCon, the Kubernetes conferences around the world, but also provides a certified Kubernetes conformance testing, and we'll key on that in a moment. But they also provide a definition, and while this definition is fairly high level and abstract, it is really important to show you the components of what cloud native is. It's really a way to build and run software. And it's a way to build and run software with more modern technologies, more modern packaging, such as containers, immutable infrastructure, and APIs. And this really fosters what we've seen as the microservices architecture, although that's not a requirement. None of these things are fixed requirements from top to bottom on how you run or how you approach or how you start to implement your journey towards cloud native. But a fully cloud native system will have most of these components fully enabled and in a mature manner. So with that, the success is just incredible out there. The amount of innovation out there is also incredible. And the fact that this many different companies and this many different projects are all working towards interoperability and advancing the state of the art for how we run the entire cloud native system, as well as the architectures and operations, this means that you can buy into all of this development to fuel your own development out of the box. That doesn't make it very simple. There's a huge amount of complexity and a huge amount of depth in any one of these topics, any one of these vendors, any one of these offerings. However, we still have that level playing field for switching technologies and evaluating a whole market to compete on these platforms and on these terms, which again is an unprecedented opportunity. I would argue there's no other way to do things. So with that, therefore, we really want to finish the justification, which is really that, oh, great, all those technologies are nice, but what do they give us? They give us the incredible amount of reaching the speed to market to reach a global audience with two very simple outcomes: agility and scalability of any business initiative. And I'll argue even further, and we'll drill down on this next, that agility is enabled by a DevOps approach towards cloud native. And not only that, when we start to try to reach a global audience and perform anywhere, we really need to remove every single point of failure. And we use the lens of pets versus livestock to expose that. Now, we're going to drill into those two things because the process of removing friction between the developer and customer is exactly what a cloud native system can enable when implemented well. But if you don't have this guiding principle, you wouldn't select the proper cloud native facilities, systems, and operations, or teams, or vendors, because you wouldn't know how to evaluate one from the other and just would blindly pick one and start there, which at the beginning may not be a improper choice for getting started, because getting started gains you the first experience so that you can throw that away and then start with a full evaluation with a little bit more maturity and experience under your belt. So DevOps becomes the way we look at how do we give agility to our business, and it's the process of removing the process of removing friction. And when I say process, this means that we re-implement it over and over again. We evaluate everything. This can be our people, our processes, our technologies, our vendors, our infrastructure, our operations, every process. We want to remove the friction between how the developer provides value to the customer. This is a business mission. This aligns every person under the organization in order to how they can share their responsibility in removing friction to deliver value to the customer. And it is a bi-directional value chain mapping exercise. How does the customer also provide value back to the developer as far as feedback in order to give them the right insights to design a better system, design better features, ship better performance? That feedback is just as important. And so that is how we gain the agility of having a continual feedback loop of the software development process. The State of the DevOps report a few years ago contrasted the early adopters of DevOps to the fully more advanced practitioners. And really, long story short, is that every developer became a 7 times developer over 3 years for one team at HP when they adopted this. And because they worked to deliver more of their code, repair sooner because it was easy to deploy anything, it was easy to remediate by just reverting a deployment. That meant that that was a vicious cycle of allowing them to automate more and feedback on this to deliver more and repair sooner. So this is how advanced practitioners of DevOps gain that agility and lift away from even the earliest practitioners of DevOps. The second lens that I want to give you for scalability is removing every single point of failure. And this has been popularized as a meme called pets versus cattle. We've genericized it a little bit more culturally sensitively to call it pets versus livestock. And again, the human nature of just everything that we do, even in cloud native, is that we will build it by hand. We will hand maintain it. We'll learn all of its characteristics. We will hand operate it. And we will do this on our laptop initially, right? And that is the process of discovery. But that is not acceptable for how we actually then collaborate with teams. We need to have our facilities not a single point of failure on a certain laptop. We want to have it on a cluster available to multiple teams. We want that cluster to be able to scale out. We want to have the ability to distribute the functions and microservices on that cluster across multiple clusters ultimately. Because any one single container or function or piece of software is able to run in multiple places on a cluster, this means that we don't remediate any failure, we just replace it to maintain our SLA. Contrast that to how we do things on our laptop. If anything breaks, I have to fix it. And this is really the entire mindset. We go from trying to scale up and throw more resources at giving things to more performance, whether as contrasted to distributing the load and scaling out. Give me more instances of my function, scale it out over more data centers so that we can manage all the traffic. So this pets versus cattle or this pets versus livestock mentality really helps us identify when people have made the mistakes of going cloud first and over-rotated by treating even, say, AWS or GCP or Azure as a pet by just deploying their workloads in a single AWS region. About 2 or 3 years ago, EBS in Amazon US East 1 had a slowdown, and 40% of the internet was affected by that slowdown in performance. That is because 40% of the internet treated Amazon as a pet. Now, given these two lenses of agility and scalability to unlock the business outcomes everybody wants, it's very easy now to lay this out on 2 axes and chart the journey to DevOps. And really, we all start off at stage 0, and we want to achieve this up and to the right magic nirvana Gartner quadrant of fleets everywhere with ephemeral data centers and ultimately ephemeral applications running on all these things, fully automated and event-driven. So this is not easy to achieve. And we will talk a little bit more, but if we talk about stage 2 architecture, that's cloud native. And we're going to drill into more detail and summarize on this slide at the very end of the presentation to show the full journey. But truthfully, most teams operate in silos and their domains of expertise. The infrastructure teams are different from the application architecture teams, are different from sometimes the operations teams, and the culture across all these teams can be different. So really, when I work with customers, I deal with many of them with stage 0 infrastructure, stage 1 infrastructure, and I have to argue with them and enlighten them that they want to start to automate their infrastructure to get to stage 2. That's just infrastructure. Then we start to, once infrastructure becomes invisible and synthesized, then we can talk about the application architecture on top of it. Is it monolithic? Can it scale up or can it scale out, right? How do we go from stage 1 to stage 2 in our architecture? And really, ultimately, how do we get to that ephemeral everywhere, global and active stage 3 architecture? But correspondingly, infrastructure operations and architectural application operations also need to combine when we talk about the full stack. And again, there's a whole progression of cultural development there. When we finally have all these different silos of how the business runs, then we can align the culture across those teams to share the responsibility to get to stage 3 culture. So yes, this journey has been conflated across many different teams, but ultimately it does align completely. And this is where we end up on the journey of fully adopting cloud native. So let's talk about that. The software development lifecycle really consists of almost everybody accepts today that continuous integration is how they tie their software and their build systems together to assure that code, whenever it's checked in by a developer, anyone on the team, can be built. It goes through a certain amount of probably unit testing in order to assure that it's in a buildable and therefore runnable state. By checking every check-in and rejecting the ones that are not buildable, that fast feedback to developers increases software quality, allows them to check in smaller changes and increases their velocity, and ultimately increases developer productivity because that feedback happens on every check-in. That means that it becomes a virtuous cycle, as we saw for DevOps, which is that developers will check in more frequently. That means smaller changes come in and the problems that they need to fix, remediate, or revert or resolve are also smaller. That's how we get that higher velocity and higher productivity. Continuous delivery builds on that to make sure that we deploy this, not just build this code, but also deploy this code to a test environment. And as long as there is automated testing there, we are completely doing application integration testing of not just the change code, but the full integration of a transaction across the entire system where that new exercise code is in conjunction with all of the other systems that support it. Again, the more we do of this automated testing of application integration, that's again where we drive another level of software quality and developer productivity up. Going even further on that, we can then determine policies for that test automation in order to schedule further delivery of this code. And that is where we get to what normally everybody calls this a CI/CD pipeline, but that D is ambiguous. Is it just continuous delivery to testing, or is it continuous deployment to automatically, once passing automated software testing, deliver and release that code to customers? And typically this can be production, but this also can be back to staging or other areas, wherever your customers are. It may be internal customers as opposed to external customers. Therefore, the difference between continuous delivery and deployment is really the destination and the amount of governance to allow that automated delivery. That gets us to the final stage of really this innovation, which is continuous operations post-deployment. It's really where we talk about the life cycle of our code and our applications. It's really the operational life cycle for the maintenance and updates of these deployments. It requires that instrumentation for monitoring, logging, and metrics to understand the service level agreements that have been enacted by your code in production on your customers, so that we can understand the value that you've delivered, as well as get the customer satisfaction, so that feedback metric comes back to the developer on how to improve things. And operations also keeps this up 24/7 around the world, accounting for failure, disaster recovery, all the exhaustions that can happen in any data center, making sure that we maintain those service level agreements, any performance impacts, and certainly all the updates as well need to happen, because we still have infrastructure that might be independently operated from the full stack. So that means we can now take all of this together and talk about how we decompose the typical monolithic value of a software into microservices, and then pick how do we want to run this? How do we want to leverage the market and vendors out there? And so I won't explain IaaS, PaaS, and software as a service in depth. However, you should have this understanding, because as soon as we decompose every function and every library of code, then we talk really about whether or not it's going to be in-house, or whether we want to run it out-house as a SaaS service from a provider, or whether we want to run it on top of a PaaS service. So really, taking a look at our current applications and our code base, we can refactor every library into its own unit, every function into its own unit. And I'm not arguing that you need to do that absolutely, but you might have logical clusters of libraries and logical clusters of functionality by team, or whatever organizational heuristic or metric you want to use. But you can decompose down to every individual library and function if you so wish. Therefore, every library and function therefore can be delegated out to a PaaS or a SaaS service just as much as you can run it in-house. And so this refactoring of the monolith is the hardest process for developers. But when we take a look at the cloud native platforms and their abilities, this is really where we put container packaging around it, public APIs around it, in order to change the application from a monolithic to a microservice architecture. And this confers us the ultimate ability to have no difference between how you build something on your laptop, how you build something for continuous integration, and how you deploy something. They are all the same artifact when we use immutable infrastructure with containers. So let's go into that. It's really a matter of, now that we have continuous integration and delivery, it's really a matter of now, how do we package our code? How do we deliver our code? And how do we deploy our code? That is the right argument to have once you've started to take this journey. And it really is, again, we start off with pets on our laptops. This is how people kind of start to put their functions or a piece of their code base into a container that's hand-built typically. And they learn about their Docker files to kind of automate at least the build of it by hand. And we've seen Docker Compose work on orchestration of more than one container together. But that's not the way people do things anymore. That's how people had to get things started 5 or 6 years ago. And even Docker Swarm, which allowed us to run containers not just on a laptop, but across multiple servers as a cluster, has fallen by the wayside and become deprecated, because what we see now is that Kubernetes has taken over the world. And running local Kubernetes is now a very democratized, easy thing to do because Docker provides it, just as much as there are other distributions like Minikube and many others. So this is what it takes to get started with container development and local Kubernetes. It's very easy to go cloud native very soon without having extremely hard infrastructure problems to solve at the beginning. However, choosing a Kubernetes distribution does not mean that everything is equal and everywhere. And that is why the CNCF created the conformance for certified Kubernetes. And we really do recommend that you look for this evaluation, or at least understand the trade-offs that you're taking whenever you do something that is not certified Kubernetes. Or worse, when you adopt a certified Kubernetes distribution and then make it proprietary, such that you are locking into a vendor's implementation. These are all the kind of pitfalls that you need to watch out for. So correspondingly, after people are comfortable with development, even local development and experience and breaking things on their laptops or even on their local systems with their local teams, it really, the progression for how to do containers in production in shared environments is no longer about Docker Swarm or even Mesos anymore. It really, over the last 3 or 4 years, has solidified onto Kubernetes. And again, the CNCF has stewarded this so that Kubernetes is not a contentious topic. It's the flavor of Kubernetes is the contentious topic at this point in time. So let's talk about those different distributions and methodologies for running Kubernetes. Kubernetes is getting easier and easier to run, easier and easier to approach, and easier to operate. However, I will not undersell its complexity. And the nature of most people is, well, I just want to run it on my servers. And then the argument becomes whether it's infrastructure as a service with bare metal or whether it's VMs. And whether that's hosted on-prem or off-prem matters not. It's just, how do we get Kubernetes up and running? If you're not willing to take on that operational landscape of Kubernetes, and believe me, it is, then we take a look at the PaaS offerings, where we have many public cloud hosted offerings from Amazon and Google and Azure, and they have evolved also to make their services better. But we have many options also on-prem with private cloud options, such as OpenShift Cloud Foundry and even our product Nutanix Carbon. The goal for these things is to make Kubernetes easy. However, we all achieve it in different amounts. And really, we've seen Rancher, also recently acquired, try to overlay all of these systems with another management control plane on that. Regardless of what the distribution and the hosting methodology and the PaaS-like experience that you accomplish once you have Kubernetes up and running, it's really then a matter of now how you populate it. And really, the industry, for the most part, has completely shifted towards Helm charts. I won't say it's done. None of this is ever done. There's so much innovation going on, but Helm charts and GitOps seem to be the most dominant evolving models for how to finally control all of this difficulty and complexity implicit in Kubernetes in production and the operational landscape required for it. So I won't go deep into containers. I won't go deep into containers or Kubernetes, much more than to say that Kubernetes configuration is all through YAML for the most part. And as much as possible, Helm charts bundles up all of the different Kubernetes objects and configurations of YAML such that you can execute them in one concrete unit and consistently take care of the orchestration of one dependency, say secrets, before you get into pods, before you get into deployments, and so on. So really, Helm charts are the simplicity way to bundle up all of the YAML. Kubernetes is often exaggerated as a YAML generating system. But what we see ultimately is that cloud native applications are evolving. While people still have their VMs and their bare metal legacy systems, they sometimes want to interoperate them with Kubernetes and container hosting, or they try to ultimately move more and more into this container cloud native Kubernetes based infrastructure. So where that is possible, you can shed your legacy and totally modernize to get to simple, stateful, containerized type 1 applications. But where it is not trivial, where you need to have more built-in systems, right, and outsource more of the operations and more of the facilities, we see the PaaS offerings being incredibly compelling and giving an incredible amount of value, but also potentially an incredible amount of lock-in if you're not careful to choose open cloud-native technologies that help insulate you from vendor lock-in. But correspondingly, we have seen the type 3 requirements really ultimately of how do we bridge the whole world inside and outside of wherever Kubernetes and our cloud native applications and facilities are running. And it's really how do we tie the whole world before and after Kubernetes into this world, as well as make sure that we can run this world inside Kubernetes and cloud native anywhere at any time. And federation is a difficult thing to do, but at least we can have redundancy and coordination on a higher level before we get to Kubernetes federation, which is still incubating. So this is really the way we've seen how people approach cloud native, and it becomes a blend of how simple to how complex you want to run your operation and how much you want to run the world in this domain. So a further example of really some of these facilities runtimes that we constantly see customers asking for, and we ourselves have evolved to make a PaaS offering, is to do this on any system, on-prem or off-prem, so that hybrid Kubernetes systems can run in multiple clouds and in multiple private locations on multiple hypervisors, so that we get this really truly hybrid world. That means that it's a process to continually evolve towards developers first packaging their functionality as containers or choosing to outsource those functions to a SaaS-like service. Then they can evolve their systems, their languages to be even more container friendly or more functional or serverless friendly as needed as they choose where to modernize, because the APIs for their code functionality are the only interfaces that are important. Therefore, the language is no longer a dependency or a full requirement. It can be changed as long as the APIs are maintained. That's how we decouple and loosely allow the federation of all of your code and functionality and libraries and providers to operate interchangeably together. And so, yes, that API ability and contract is essential to maintaining these systems. Therefore, it's now a matter of how DevOps can start to build all this stuff into CI/CD pipelines with increasing automation, increasing testing in order to guarantee a minimum amount of quality, a minimum amount of security, and a minimum amount of conformance and governance on how your deployments are operated. So that's really where we get to the final stage of continuous operations and policy-driven allocation. So there's many ways to do this. That's the wonderful thing. You have too many choices in front of you. And the truth is, you really need to respond to your business requirements first and foremost. Whether you need to run under an operational expenditure model, a capital expenditure model, a blend of these two things, that is up to you and your business stakeholders for how to manage your risk and how to manage your finances. Correspondingly, compliance, performance, and control also of your data as well as your operations can also factor into running on-prem, running off-prem, running hybrid. So if all of this has worked out well, then the final stage is, right, it's not an argument of how we're going to do this. It's not a matter of where we're going to do this. It's not a matter of why we're going to do this. It's really a matter of what are we going to do now and how are we going to take this journey. And so what we've talked to customers and what we consistently hear is that they need Kubernetes to be one click as much as possible and delegated. So that the developers can run an experiment, break Kubernetes, throw it away, and start with another ephemeral Kubernetes cluster so that they can learn, and that the CI/CD pipelines are not pets, but they are livestock. They are also repeatable, they are mutable, they are experimentable, and then we can share the features that we want to improve our CI/CD pipelines, our Kubernetes deployments and configurations. All of those things now become software driven and can be shared and collaborated and managed as software artifacts and releases. But correspondingly, the infrastructure and business requirements for cloud strategies and optimization is also a key concern after we've gotten through all the technical ability and methodology. And really, this is how we confer and go all the way back up the stack to gain as close to the business requirements as possible. Ultimately, it's that this needs to be run simply from a single pane of glass as much as possible. And that is really when we finally get the continuous governance and operations that every business demands. And if you can build all of those requirements into the beginning, then your selection of vendor and your selection of technology and your selection of methodology will become very clear when you see this end result as your business requirement at the beginning. So I will repeat an earlier slide and now point out that cloud native infrastructure is really Kubernetes. That argument is for the most part one and done. It's now a matter of where you want to host Kubernetes, how you want to operate Kubernetes, and how deep you want to go into Kubernetes management. Correspondingly, stage 2 architecture is cloud native facilities on top of Kubernetes. That's all there is to it, right? We get distributed systems that have wonderful APIs that are built to be distributed and scale out. Ultimately, then, the operations becomes the next contention. And as long as your CI/CD pipelines now confirm all the way with the state of the art on GitOps to automatically allow a developer to pull things to production on Kubernetes clusters in production, that's how we get to completely cloud native operations. So that's how we get to stage 2 culture. And as you can see, stage 3 architecture, infrastructure, operations, and culture is now what you're able to accomplish once you've gotten to the cloud native journey of stage 2, maturity. So that's where we're going to stop right now. I've covered a lot of ground. There's so much more rich depth in any one of these topics. I'm happy to share any of my experience and our customers' experiences out there. And we'll open it up to questions. What do you think, Charlene?
All right. Yeah. I got plenty of time for questions. So if you do have a question for Mark, please go ahead and use your GoToWebinar control panel and go ahead and get your questions on in. Let's see. We have one quick question here, which is, what are some of the most common pitfalls to going cloud native?
I would say the most common pitfall for cloud native is to only accept one way to do things. As I said early, this is a process of discovery and maturity. I'll go back to this slide, right? And typically people work with their incumbent vendors to get to a Kubernetes or a cloud native solution if they offer it. And that is a logical place to start. However, it is not a logical place to conclude. It's not intellectually honest unless you go back and take a look at the entire cloud native landscape and find all the other vendors that compete so that at least you can do a market assessment of what your incumbent vendors offer. Correspondingly, the skill sets required to embark on this journey and to mature continuously on this journey is also a huge challenge. And unless your management has bought into the retraining and expanding of your skills, and not only that, bought into the ability to fail to learn. And what I mean to fail to learn is you are able to fail fast with your experiments, learn from those things, and improve. That you have to be able to fail frequently. obviously in development, not out in production, but you need to fail frequently so that you can actually gain this knowledge, because this is not something you can get a college degree for. This is something where we look at the massive online courseware for potentially getting a leg up on it. But the state of the art is really the developers and vendors who are innovating and checking in everything. Kubernetes just changed during the span of this discussion, right? So that is the point, is that you get started, but be willing to throw things away, because you need to gain the experience in order to evaluate the market and evaluate your next steps, so that you can be agile in how you approach improving your infrastructure, operations, architecture, and culture. That's about it.
Okay. All right, great. Got another question here for you. Can you please talk about the 4 levels once again?
Oh, sure. Really, if you remember, we were trying to get rid of all of the single points of failure, and that's really where we are at stage 0. Everything is hand-built, a pet, hand-maintained, and dealt by with one team on one server or in one data center, on one vendor, on one infrastructure, on one cloud provider, right? The single-threaded nature of all of this is the pet nature of these things, right? Therefore, we have an emotional attachment to them. We want them to have the longest lives and longest uptime. But the truth is, when there's more of one of anything, this is when we've driven into the scalable world. And that scalability is the key towards cloud native operations and architecture and infrastructure. We can't have one Kubernetes cluster. We want to have an ephemeral Kubernetes cluster that anybody can spin up anywhere at any time to do anything. And if you can't do that, you have locked yourself into a pet vendor of Kubernetes. This is really how I try to kind of make that point over and over again. That's the difference in maturity. You know, it's okay to start with a totally pet Kubernetes distribution on your laptop. Absolutely perfect place to start. But do not hold yourself to that for how you're going to go to production, and not how you're going to do that as soon as 2 developers need to work on Kubernetes. How do you put it in a clustered scenario that you can share? And then how do we make sure that production, which might run in a different data center on a different provider, is really just a different instance of what development is? Because the more we make development and production different pets, the less interchangeable they are, the more risk we have when we go between development, staging, testing, and production, right? And so that's the mindset of really how we go from stage 0 to stage 3 of anything. So to belabor that a little bit more, on culture, it's a lot of people say, hey, you know what, we need to get a DevOps team to be the smart people that can, you know, talk to the developers, talk to the operators, and start to bring all these kind of GitOps and operations and CI/CD pipelines and all this other stuff, and work with all those technologies and work with the public cloud and the private cloud vendors. And ultimately, yes, that's true to get started. But in a mature organization, there is no DevOps team. Everybody is DevOps. We all share in these values. We're all iterating towards cloud native facilities for their infrastructure, architecture, and operations, and our culture, so that we can get to stage 2 everything across the entire business, share in that responsibility. And therefore, the DevOps team is democratized, is every team, is the operations team, is the engineering team, is the infrastructure team, is the culture. And that is really the difficult part of the maturity stages that people don't see unless they already know what the end result should be. And I've presented it here. It's stage 3 culture ultimately has these impacts on how the stage 3 infrastructure, architecture, and operations enable you to have data-driven experiments, so that nobody says the best way to do thing is X. Well, let's do X as an experiment and prove that X is actually better than Y, because somebody else is going to have another way, a diverse way, another way of approaching the problem. And as long as you have the ability to iterate in an agile fashion, you can do developmental experiments easily and continuously deploy them, continuously measure them, and drive the answer, is X better than Y, and why? And then figure out from a data-driven manner with metrics whether or not we measured the right thing to actually have the argument to say X is better than Y. or vice versa. So that's the cultural experimental way of kind of scaling your culture across all of the organization and sharing in the benefits of cloud native development. It's really that kind of approach that I think I've hopefully now shown you where you can end up, because this is exactly how Netflix operates. This is exactly how Facebook operates. And they do this at an unprecedented scale with global audiences. So the methodology and the culture, that we know what the aspects are. Of course, you need to adapt them to your business needs and your culture, right? And perform the right hybrid between these things. Arguably, not everybody wants to be Netflix or Facebook culture. However, their methodology and their scalability and their agility is unprecedented and undisputable. And I think we've shown you exactly the path to get there.
All right, great. Lots more questions have come in, but there's still plenty of time. If you have a question, please go ahead and use your GoToWebinar control panel and submit it, and we'll try to get to lots more. Next question here for you, Mark. Would you consume event-driven pipe, e.g. Kafka, from within the Kubernetes cluster, or consume it as an external service? I feel like it is where the vendor lock-in can come from.
Yes, that's absolutely true. And you've pointed out exactly the crux of what is your business requirement. Is it to get a Kafka-like functionality to support your developers? Does it confer a business advantage for you to run it and control it yourself and invest in it so that you have that operational overhead? Or is the right thing to experiment with it with one vendor, but make sure that you're working with definitely not a proprietary version of Kafka? Proprietary might be a different set of APIs wrapped around it, a different set of operations around it, a different set of black boxing of it to make sure that you are vendor locked in. If that is the case, then yes, you have to figure out whether the trade-off for, all right, let's get our feet wet with Kafka, with a PaaS or vendor locked in black box solution is the right way to just get started, but let's not commit to staying there. Let's commit to also factoring in our sprints that is technical debt, operational debt that we will need to refactor out in order to go to a more generic Kafka, because now that we've gotten our feet wet, now that we have experience working with, say, a PaaS or a black box implementation, now we can take on the first steps of trying to bring it in-house, run it ourselves, or run it with a different vendor, or run the most generic open source version so that we can stay closely aligned with the project and upstream providers. And then that's how you reevaluate the vendor market, again, against what is your business requirements. Do you have the budget for this? Was PaaS too expensive? Is hiring an operations team too expensive? Or do we have operations teams that are willing to now contribute towards the development operational code base with GitOps of how to make testable with metrics Kafka operations? So again, it's all of these things. I've only tried to give you the landscape for which and the lenses for which to evaluate the landscape. Those decisions ultimately come down to you and your business owners speaking frankly, and also speaking frankly about how to change. No one decision should rule the rest of your lives. Then if that's the case, then you are not an agile organization and you do not have agile culture. It's really, let's try to do something and invest for it for the next 3 months or 6 months or whatever your comfort level is. But at the end of 6 months, let's then schedule another 3 months of evaluating and then potentially another 3 months of migrating, right? So that we've doubled our timeline for how we're going to mature the capabilities and mature our culture and mature our infrastructure architecture and operations. When you now have this landscape and you buy in with that with your business owners from the get-go, this means that you are an agile organization and your culture is adaptable because you've already planned for that adaptability. And yeah, that was an excellent question. You've hit on all of the concerns that my customers have and sometimes don't even know how to ask. And that's why we have this kind of rubric for how to evaluate everything.
Okay, all right. Here's a really interesting question for you. We are using all the things you named, microservices, DevOps, containers, etc., in an agile manner. but on premises only. So why are these things called cloud native while you can use them successfully without any cloud at all?
Oh, well, I should have included my other slide then. Long story short is that cloud is an experience. While the term was popularized by the rise of the public cloud, and Amazon Web Services are due all credit for really helping drive the industry and leading the industry. Cloud is an experience, and the National Institute of Standards and Technology back in 1990, actually, excuse me, I think maybe about 10 years ago, and I really wish I could pull up the slide. Maybe I'll blank and bring that up. Defined cloud as an experience which can be public, private, hybrid, can be completely PaaS, can be completely SaaS, can be completely IaaS. So cloud is really an experience and a continuum of multiple vendors such that you really are not locked into one mode. It has been popularized by public cloud, and everybody makes the mistake of conflating cloud with public cloud only. That is a mistake. The truth is that that is why so much of the industry, including our US government, spent going from being cloud first and over-rotating on public cloud to find out that they had not modernized their workloads, had gone to a completely OpEx model, and were overpaying things. It was not cheaper to run 24/7 legacy workloads in the public cloud. So they've retreated it and they repatriated workloads back on-prem, but they had not modernized on-prem to be a private cloud and had not done the technical debt that was required to start to go cloud native in application refactoring. All of that is now the CIO of the US government's mandate is not to be cloud first, which was public cloud first back then, but now to be cloud smart, which is application rationalization for what is the right form factor of your applications, their operation, and the infrastructure vendor that provides it. Whether that's hybrid, which is what everybody, all of the public cloud vendors are evolving towards, and what all the private cloud vendors are evolving towards, or whether it's just public or whether it's just private, doing any one of these things makes it a pet architecture. The truth is, to become livestock and cattle, we really need hybrid cloud everywhere. So to summarize, private cloud is an aspect of public cloud, is an aspect of hybrid cloud, is the evolution of all of this, regardless of where you start. We all know where you're going to probably end up, so that you can have the best of both worlds, a blended experience of CapEx and OpEx, a blended experience of on-prem and off-prem, a blended experience of full control to full delegation of control, a blended experience of governance and running the workloads on demand where they meet the business requirements. Your compliance requirements might require full control on-prem in your data centers, whereas the web front ends or analytics might be completely ephemeral, batch driven at the end of the month, and totally makes sense to expose your data lake to the public cloud for a weekend run at the end of the month to do large reports. Hybrid and cattle and not doing that single point of failure, making anything a pet, is really the journey that we're all on.
Excellent, excellent. Okay, so doing a quick time check, we're about 12 minutes to the top of the hour. I think we have another 7 or 8 minutes for questions, and then we'll go ahead and close things down. Here is another one for you. Thanks for the session. There is a known issue of stateful applications and databases in particular to implement on top of Kubernetes. Is there a seamless way to address this, and could you share some approaches?
That is an excellent, excellent question. Right. So yes, most people think, yeah, I've gone cloud native, I got everything in containers, I've done immutable infrastructure. Where does my state go? Where do my transactions go? Right? Where does my persistence go, in essence? And while we see the evolution of cloud native databases, no SQL being, probably the preeminent and easiest facile way to approach these things, that is not a panacea for how to do everything. And relational databases and all the other esoteric forms of databases, which have huge amounts of storage requirements and accessibility, really makes these things muddier and muddier. Now, that is not to say that every database can't be containerized. It absolutely can. Does that mean that the operations are also containerized and that the disk state of operations for persistence is also fully operationalized? No, that is an evolution of the entire industry right now. And so that is quite frankly where it is not arguably the right thing to do as cloud native. Maybe the more agile, immutable, flexible front ends of your business, which are very transactional, but only transactional during program execution, not at rest, right? There is no necessary state other than the current running state. All that state needs to be exported ultimately to that backend persistence of databases, as the question really infers. That's really the argument for maybe staying things to be more traditional, leveraging your current skill sets of your DBA teams, but asking them, can you give me a relational database? Can you give me a session key store? Can you give me these types of facilities for my microservices architectures in Kubernetes? And then we can argue about where it's hosted. And then can you give me the right storage capacities? And then can you give me the right storage disaster recovery? And can you give me the right performance guarantees and SLAs, right? Can the infrastructure architecture and operations of a database or a persistent state and storage be satisfied in cloud native? And that is a very difficult question right now. For lightweight business requirements, it's absolutely eminently doable. And we see vendors innovating on, database backups and stuff like that are completely cloud native, and we have cloud native storage as well, right? And I won't say that those are a panacea of absolutely rock solid solutions that outstrip the current state of the art in, more traditional infrastructure and operations, but they compete. And if your business requirements are low enough, then you can work with your current teams and their skill sets to evolve to, all right, let's try to do stateful databases, persistent volume stores, and so on, and therefore disaster recovery between clusters for persistent state or shareable state as a goal. And you start to chart that journey for the cloud native databases. But I won't say that it's easy, because it's not. And I won't say it's done, because it's not. And I won't say that it's better when it's cloud native, because it depends on the business requirement. But for the most esoteric and for the hardest and the biggest enterprise business requirements, it's not good enough at this point in time. But that's changing every day. So work with your business constituents, work with your database administrators, and evolve together. You'll get there. We'll all get there as an industry. I hope I answered your question sufficiently. You can reach out to me afterwards if you want to discuss further. It was an excellent question.
Yeah, all right, great. Let's see. Looks like, sorry, I'm just going through the questions here. It looks like the majority of the other questions, yes, the presentation slides are going to be made available to anybody following today's webinar. We'll be sending out an email that contains a link to access the webinar on demand, and the slides will be as part of that. And it looks like that's pretty much all the other questions that we have from the audience right now. A couple comments here and there, but as far as questions go, that's pretty much it. So I'm going to go ahead and close out the question and answer period now. I do want to just remind the audience, if you do have a question for Mark, you can still go ahead and add it to the GoToWebinar control panel, the question section, and Mark will get it. If we have time before the end of the webinar to address it, we certainly will. But thank you to everybody who did submit questions. Lots of really great ones. I'm really impressed by them, actually. Also,
I just wanted to follow up on that one question. Here's the NIST Special Publication 800, and it was published back in 2011. This is the definition of cloud. And as you can see, the deployment models include private cloud. So you are cloud, and you are cloud ready, and you are cloud native.
Excellent, excellent. Not as ethereal as the public cloud, but private cloud is also very much the cloud. So good stuff there. Good stuff there. Okay, want to also remind the audience real quick, as I said, that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. We are going to be sending out that link after today's webinar that contains a link to access the email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you can always go look for it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay. Let's see, I did mention at the top of the hour that we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's go ahead and do that real quick. Our first winner today is Eric P. Congratulations, Eric. Our second winner today is John R. Congratulations, John. Third winner today is Jose C. Congratulations, Jose. And our final winner today is Teresa R. Congratulations to all 4 of you. We'll be following up with you via email following today's webinar to get your gift card over to you. And check your inbox. If you don't see it in your inbox, please check your spam folder. Mark, such a great presentation. Thanks so much for your time and your expertise. Lots and lots of good stuff there. And like I said, judging from the types of questions that we got in from the audience, definitely worth the time and effort.
Thank you. Thank you. Please reach out to me if you have any further questions. It'd be my pleasure. Thank you again to Jade and Clarice.
All right. Okay. All right. This is Charlene.